Alright, in this video we are going to make our asteroids destroyable. So the first thing I'm going to do is I'm going to get rid of this cube. We were using that cube earlier just to get a perspective of how the player was moving around, but since we now have an asteroid field, that's irrelevant. So I'm just going to nuke them. So let's go ahead and look at our destroyable script that we wrote a while ago. The destroyable script is actually going to be used for our asteroids to allow them to be destroyed. So I want to use it for both the asteroids and for the player itself. Now, this brings in an interesting topic about reusing mono behaviors inside of Unity. Unity has quite a few features that allows us to reuse different mono behaviors in different situations. One of those features is its messaging system. So what I'm going to do is I'm going to fill out this destroyable class by adding in a method called public void take damage. Take damage will have damage and then game object from. So the take damage method will be invoked when any object with destroyable attached to it takes any sort of damage, and it'll tell it how much damage it took and who it took it from. So the first thing I need to do is I need to say health minus equals damage. But what do I do now? Well, I need to notify this game object that he took damage, and then if his health goes under 0, I need to notify the game object that he was destroyed. But I don't want to actually explicitly tie my destroyable into a specific kind of game object. Instead, I want to make it reusable between both our asteroids and our player, as we already are using it on our player. So to reuse this on the asteroids, we have to make sure that we're not hard coding anything to the player. So what we can use is the send message method. So I'm going to say send message took damage. Then I'm going to say send message, from, and then send message options. Come on, you can do it. Don't require receiver. Then I'm going to say if health is greater than 0, return. Otherwise, send message destroyed from send message option. Come on, you can do it. There we go. So what's going on here? Well, when we take damage, we send a message to the game object saying that it took damage, passing in a parameter from the from, which is the game object that instigated that damage. If he took our health lower than 0, we send the destroyed message. Now, a message is basically it's a message that's sent to the game object. It'll be picked up by methods that are named the same as the message name that we're sending. So, if we have another mono behavior on the same game object, for example, don't write this code down, I'm just showing an example, that had took damage game object from, this method, if it existed on a different mono behavior on the same game object, will be invoked whenever the took damage message is sent to that game object. So it allows us to write a destroyed method and a took damage method on both our players and our asteroids to give them different behavior when they're destroyed or when they take damage. So I said that I wanted this attached to my asteroid, but I still need a way to invoke the take damage method if our projectile hits something that actually has the destroyable component attached to it. So what I'm going to do is I'm going to jump into my projectile class and I'm going to write a method on it. And this method is going to be public void on trigger enter collider collision. Then I'm going to say var destroyable equals collision dot get component destroyable. Destroyable is null. Then return, because he collided with something that wasn't a destroyable. But if he did collide with a destroyable, invoke the take damage method, passing in the damage that our weapon returns, so weapon.damage, and the game object that the damage was sent from, which is our projectile, and then finally destroy the projectile, because the projectile has hit something, it needs to be destroyed. So the onTriggerEnter method will be invoked when the rigid body attached to the projectile hits a trigger volume that is defined by a collider, which means that we now need to do two things in order to get this to work. We need to attach a collider to our asteroid, We also need to attach the destroyable script to our asteroid so that when our projectile hits it, the onTrigger inner method will be invoked, it'll retrieve the destroyable component out of it, and it'll invoke the take damage method. However, I will do one more thing for debugging purposes, because I want to jump back into Unity and get everything configurized first before I move on. But to make sure that I know that these messages are being sent properly, I'm going to go to the asteroid class, and I'm going to scroll down to the bottom, and I'm going to say public void destroyed game object from. Then I'm simply going to say debug log destroyed. So I'm just leaving that in there as a little temporary thing so that we can see if this is working. So the two steps that I need to perform in order to get this to work is to go into my asteroid prefab and to attach a collider. Now the collider that I'm going to be attaching is going to be a capsule collider, because I think that will that'll guesstimate the collision of the asteroid just fine for our purposes. And I also need to attach the destroyable script to the asteroid. So I'm going to go down here and I'm going to attach it. Now the destroyable script requires a health and a max health. I'm going to set the health to 50 and the max health to 50. This will be replaced by the level, or computation based off the level of the asteroid, so that bigger asteroids are more difficult to kill. But for now, this will serve our purposes for testing. So I'm going to hit play, and I'm going to shoot at an asteroid, and I'm going to see what happens. So we see that our projectiles are indeed getting, let's see if they're getting destroyed even. I'm going to shoot at this guy, and there shouldn't be any projectiles behind him, which I can't tell if there are. So let's back up to my projectile. I'm going to add a debug log in here. I'm going to say debug log collision.gameObject. Now I'm leaving this in here in this video because collision is very complex. So we're going to go through all the debugging steps to figure out why our collision isn't happening. Now we see that our projectiles are colliding with our mesh, and that is the mesh attached to our player, but that's fine. I don't really care about that. That's not going to do anything. But we see that they are indeed not being hit by the asteroids. Otherwise, we would get a different message there. So what I'm going to do is I'm going to pause the game and I'm going to zoom in on an asteroid, and I'm going to see if its capsule collider is set properly. Actually, I think I see the problem right here, is I don't think I set the is trigger on the capsule collider. But I did set the is trigger on, no, I didn't set that on the projectile either. One of these colliders has to have the is trigger flag attached to it, and I'm going to set the is trigger flag on my asteroid collider. So by setting is trigger is true on that, we now are destroying asteroids. Now you see that they're not actually disappearing or anything because we don't have any logic other than that little debug message. I'm looking down at my console and I'm seeing that indeed we are getting the appropriate messages saying that these asteroids are being destroyed, which means our code is working. So now that is trigger is set to true, we need to make sure that we add a rigid body to our asteroid. And that's because our asteroids are moving. Now, when you just have a collider attached to a game object in Unity, that becomes a static collider. Now, what that means is that Unity is going to perform some optimizations in its internal data structure that assume that the object doesn't move. This will cause problems when we do have our object being moved, in that it'll confuse Unity's collision detection and will result in unpredictable behavior. Adding a rigid body will force Unity to put it into a different data structure for its internal collision detection and will make it possible for that object to move around in the scene. So to do that, just scroll down on our asteroid prefab, add component, and type in rigid body. Make sure that we uncheck use gravity and we check is kinematic. So now we won't have any issues with our asteroids moving around the scene.
Yay!
Okay, so jumping back into Visual Studio, I'm going to remove this debug log out of my onTrigger enter on my projectile. I'm going to jump back into my asteroid, And let's go ahead and implement the destroyed method. So what do we want to do when we destroy an asteroid? We'll be expanding this a little bit more in the future, but for now, what we need to do is we need to tell the asteroid manager that this particular asteroid was destroyed so that it can deactivate the asteroid and then reuse it later. So what I'm going to do is I am going to add a reference to my asteroid manager from my asteroid script. To do that, because my asteroids are not ever created other than the start of the game, I'm going to use the find object of type again. So I'm going to add a private asteroid manager field, and then on awake, I'm going to say asteroid manager equals cast to asteroid manager, find object of type of asteroid manager. So again, it's not particularly efficient, but it's irrelevant because our asteroids are only created at the beginning of the game and never recreated. Now that we have a reference to the asteroid manager, we can notify the asteroid manager when we're destroyed. So scrolling all the way back down to our destroyed method, which remember is invoked by the destroyable script, I can say asteroid manager dot asteroid destroyed this. So I can just tell the asteroid manager that the asteroid was destroyed and something needs to happen. Now I haven't written this method yet, so let's jump back into the asteroid manager and do that. Jumping back into the asteroid manager, we can add the method for asteroid destroyed, which we can use to determine what should happen when an asteroid is destroyed. Now, in this case, the first thing that we need to do is we need to deactivate the asteroid. So that's all good. Then what we need to do is we need to determine if the asteroid is above a certain level. If it is, I want to create sub-asteroids. So what I'm going to do is I'm going to say if asteroid.level is smaller or equal to 3, then return. That means I don't want to create any sub-asteroids in the field. However, if the level is greater than 3, I do want to create sub-asteroids that seem like they're flying out of the asteroid that was just blown up. So to do that, I can go ahead and calculate how many I want to create. So I'm going to say var to create, and this is another instance of something that you can play with, because I'm simply going to say asteroid.level minus 3 multiplied by random.range 1f to 2f. Now you can change this to whatever behavior you want to get the amount you think is appropriate. Then I'm going to say for var I equals 0, I smaller than to create, and I smaller than asteroids count, I++. So we're going to loop to either how many asteroids we need to create or however many asteroids we have. Then I'm going to say var inactive asteroid equals asteroids at I. If inactive asteroid is active, then continue. And then we want to activate a sub-asteroid of inactive asteroid, comma, and then asteroid.gameObject.transform.position, because that is the asteroid that, or that's the location that we want to create, or that is the location that we want to create the asteroid in. Then I'm going to say to create minus minus, which means that we have created an asteroid, so we have to create fewer of them now. Or, yes, no. Something's wrong with my logic here.
Okay.
We want to say if I is smaller than to create. That is not true. We want to say while to create is larger than 0. And I is smaller than asteroids.count.
There we go.
That makes more sense.
All right.
Okay, so as ReSharper is so helpfully telling me, I haven't actually implemented the activate sub-asteroid method yet. Now the activate sub-asteroid method is going to be very similar to the activate asteroid method, except for it is going to be taking in an existing position into account. In addition, it's going to create asteroids of a smaller size. So because it's going to be so similar to my activate asteroid method, I'm just going to go ahead and copy and paste this. So I have two activate asteroid methods now, and I'm going to rename one of them to activate sub asteroid, and it's going to take in a vector 3 spawn next to. By doing that, you'll notice I haven't changed any of the code yet, but if I scroll all the way back up, we'll see that this code is now working because I have implemented the activate sub asteroid method. But now let's go ahead and change its behavior just a little bit. Instead of the rotation and direction, that's all fine. I want to leave that the same, but the position is going to be a little different. The position is going to be the spawn next to vector plus the direction times 5. So what that means is the position is now going to be where the old asteroid was plus 5 units in the direction, the random direction that was chosen. Next up, I want to modify the scale a little bit. I'm not going to be spawning any massive asteroids with this particular scale, so I'm going to remove the ternary and simply leave a instantiation of a new vector 3. And then I'm going to change the parameters a little bit. I'm going to change it to 15F to 40F. So they're always going to be just a little bit smaller. Now you can extend this logic to your heart's content. There's a lot of fun stuff you can do with that, as far as creating additional asteroids that are smaller than the ones that were exploded.
Okie dokie.
Okay, so what this will do now is if I come back into my game and I find a big asteroid and I blow him up, we see that he creates little asteroids. And the bigger he is, the more those little asteroids are created. You'll also notice that if I ever have more than the max amount of asteroids on the screen, I'll never spawn more than the max on the screen. So that's a nice little performance consideration. But anyway, so now I'm kind of just having fun right now. This is entertaining, which I guess is the point, isn't it?
That is the whole point.
Yeah.
We should be having fun.
Okay, so I have my, let's blow up a few more. Sweet. So yeah, so now we have our awesome little spawn guys. I kind of do actually want their velocity to be a little bit different. I want them to have a default higher velocity. So let's say between 20F and 35F. So that way the sub-asteroids that are exploded after the main one they fly away a little bit faster. But anyway, you can modify this to suit your needs, and it will be great.
Indeed.
We're missing one more piece of the puzzle, or actually a couple, but one of the ones that we're missing is we need to be able to set our health of our asteroid based on its level. That's actually very easy to do. We simply need to get a reference to our destroyable script from within our asteroid. To do that, I'm going to create another private field called destroyable, of type destroyable, and on awake, I'm going to say destroyable equals get component destroyable. Then I'm going to scroll all the way down to the init method. And if you recall, the init method is where when the asteroid becomes activated, this is what's invoked by the asteroid manager, and I'm going to set the health of this asteroid based off of its level. So I'm going to say destroyable.maxHealth equals destroyable.health equals level times 100. So an asteroid with a level of 600 or 6 will have 600 health. An asteroid of level 1 will have 100 health. Let's make sure I didn't just completely destroy the balance of this, because I think my weapons might be a little bit too weak. Yeah, they can be a little stronger. So remember, if you need to update your the strength of your projectile, just go into your prefabs, basic weapons, open up level 1 projectile, and let's give the damage, let's do like 35 or something. That should make them a little bit easier to explode, but it should make a noticeable difference between the big asteroids and the small asteroids. All right, so next up, I want to have the player's health be used. So what's the player's health even used for? Well, when an asteroid hits a player, we want to damage the player some. Now, if you recall, the player does indeed have a destroyable script attached to it. So what I need to do is I need to write an onTrigger enter method on my asteroid, and if we hit a player, or any other destroyable for that matter that isn't an asteroid, we need to tell it that it took damage. So at the bottom here, I'm going to say public void onTrigger enter collision, or sorry, collider collision. You'll notice something weird about when I write onTrigger enter. I always do collider collision. Technically, there is a type called collision that you could use for a collision, but the reason I do collider collision is because if you try to do collider collider, what would happen is this parameter would hide a property called collider on the game object itself, which is undesirable. So I slightly change the phrasing of that word to make it be kind of the same root word, but not conflict with an existing word that is reserved on, well, not reserved, but used on mono behaviors. So the onTrigger enter of my asteroid, let's go ahead and start this. Let's do this slowly. I'm going to say debug.log collision.gameObject, because it's going to show us something very interesting about the way this is set up, or the way we've set up our scene, and it's going to introduce a very interesting problem that you are likely going to encounter, well, quite a few times through doing development in Unity. So what I'm going to do is I'm going to jump back into Unity, and I'm going to try to run into an asteroid. I'm going to see what gets logged in the console. So what do you see wrong with what's in the console right now, Steve? There's something kind of weird.
Oh, the frame rate's really going batty on me.
Okay, well, the problem is that our mesh collider on our player is attached to our mesh, which is a child of our player, and our player is what has our player and destroyable script on top of it. When you use a lot of child game objects, like I like to do, to make sure that we can position and rotate our meshes appropriately, and you're using things like mesh colliders, which will require that you attach the mesh collider to the same component that has the mesh filter on it, you'll run into the situation where your colliders will be on different game objects than the scripts that you actually want to process when a collision happens. So there's actually...
And then it's not going to work?
Well, it's just not... Yeah, because right now, the asteroid is thinking it's hitting this game object and not the player.
Gotcha.
Now, we could do something incredibly disgusting. We could do something like checking the parent of the game objects to see if it has a destroyable script on it, but I find that to be less than ideal. So alternatively, I've actually came up with a solution to this problem that is fairly reusable to pretty much any instance where you want to effectively proxy a game object that has a collider on it to another game object that has your actual behavior on it. And I call it a collider proxy. It's actually very easy to write. We need two classes. One is going to be a mono behavior called collider proxy that inherits from mono behavior, and it has a public game object proxy4. Now that's all the mono behavior needs on it. However, we still need to write an implementation of get component that is aware of the existence of the collider proxy mono behavior. So we're going to do that in the form of an extension method. So I'm going to write a class, another class, and we're just going to call it game utilities, or how about game extensions? That sounds better. And this class is going to be extension method class, which requires that it's static. And I'm going to write an extension method on game object. It's going to be public static t find component. It's not going to be called get component. It's going to be called find component of t. This game object that, where t is component. Now, as far as this syntax, don't freak out about it. This is just the syntax that's required to make a method that will look almost exactly like a method invocation of get component. So if you're not familiar with generics or generic type constraints, that's not actually the point of this method. The point of this method is simply to try to get a component directly on a game object, and if that fails, to see if that game object has a collider proxy. If it does, then it tries to get a component on the collider proxy's proxy4 property.
Okay. That actually made sense.
All right, so the syntax is a little terrifying, but that's irrelevant, is what I'm trying to say. Also note that using Unity Engine came up on top. So what I'm going to say is var component equals that dot get component of t. Then I'm going to say if component equals null, return component. And when I say component equals null, return component, I actually mean component does not equal null, return component. Then I'm going to say var proxy equals that get component collider proxy. If proxy is null, meaning the game object does not have a collider proxy on it, return null. If proxy.proxy4 is null, then debug.log warning collider proxy didn't specify, but it was a proxy4. So this is just a simple little warning that that you'll see in the log if you forget to set the proxy4 property. And then finally, we'll say return proxy.proxy4.get component of t. Now, you'll notice that this method is in its, if it does hit a game object with a collider proxy on it, it's about three times more inefficient than just one get component invocation, which isn't something you really want to do very often. So just follow the same performance considerations that you would have with get component, and don't do this a whole lot. Doing it with collisions is perfectly acceptable because collisions, in the grand scheme of things, rarely happen, and when they do, there's typically only one of them. So it's perfectly acceptable in this particular case. Now, everything on the screen, I want to point out to anyone who isn't familiar with generics or extension methods, one of the most common mistakes I see with people who write them is forgetting a couple of the major keywords. I want to point out that having this class be static and having this method be static is significant, as well as the this modifier on the game object. If you're missing any of these things, then things aren't going to work. But I promise this is the scariest code that we're going to have to write in this video series. So
that's not too bad.
Yeah. So now that we've done that, what we can do is I'm going to go to my asteroid class, and on its onTrigger enter, what I'm going to do is I'm going to first make sure that the collision is not an asteroid. Now, we can also handle this through, or we will be handling this through collision layers, which we will take a look at momentarily. So let's go ahead and take advantage of that new find component method that we wrote. What I'm going to do is I'm going to say var destroyable equals collision dot gameObject dot find component. See, this is a new method that just appeared on gameObject because we created it as an extension method. And the component I'm going to be finding is destroyable. Then I'm going to say if destroyable is null, return. Now, if destroyable is not null, we want to tell it that it took damage. So I'm going to say destroyable dot take damage. I'm going to say level times 50, and I'm going to say it was instigated by gameObject. Now, this should result in our player taking damage. It'll also result in our asteroids colliding with each other and them taking damage, but that's fine. I don't really care about that for now. I just want to make sure. It doesn't seem that our player is...
Doesn't seem like we're taking damage.
Nope. Okay. Let's come back here. Destroyable, take damage. Let's go ahead and do a debug log. Took damage. Oh. So so excited to get the implementation of the collider proxy out of the way, I forgot to actually attach it to the player itself. So I'm sure people are sitting there like, yeah, you just wrote this huge thing. What are you doing with it? Well, here, I'll show you what I'm doing with it. I'm going to find the child component on my player that has the mesh collider on top of it, and I'm going to click and drag collider proxy onto it. Then I have to tell it what it's a proxy for, so I'll click and drag player onto that property, and then I'll hit play.
Now let's see how we do.
And there, we just pretty much died. Let's go ahead and make our player, let's say he's 600. Taking about half damage. Let's do 1200. You can fiddle with these like all day, seriously, like just to get the balance right. But I just want to make sure that I don't completely die when yeah, I think that's good enough.
The point of this is, don't hit a really big asteroid.
Yep. I mean, you see why I made the whole level thing, right? So that like different things are adjusted depending on the level of an asteroid, which is determined by its size. Okay, so now we're going to make it so asteroids can't collide with each other. It's actually very, very easy to do inside of Unity, because as of Unity 3 something, they introduced what are called layer masks for collisions. However, layer masks require that we take a step back and talk about layers. A layer, I'll show you an example. If I open up my asteroid, we'll see that it has a tag and a layer. Now, both of these things are used for a variety of purposes. We're going to use them in order to make sure that asteroids can't collide with other asteroids. So what I'm going to do is I'm going to click this drop down on layer, and I'm going to say add layer. And we'll see that there are 7 built-in layers. But I want to create a user layer, so I'm going to go to layer 8, and I'm going to say asteroid. And hit enter. Now if I go back to my asteroid prefab, I can click on the layer drop down again, and I can select asteroid. So now I've marked every asteroid that's instantiated from this prefab as being on the asteroid layer. I can prove that by playing and then pausing and clicking on all my asteroids. We see that they're all on the asteroid layer, right? So that's cool.
Yes, indeed.
So what we can do now is we can make it so that collisions do not happen between asteroids. To do that, I go to Edit, Project Settings, and Physics. And what we have right here is a collision matrix, which is very difficult to see. Okay, so what I'm going to do is I'm going to uncheck the asteroid-to-asteroid relationship. So asteroids cannot collide with other asteroids. While I'm at it, what I'm going to do is I'm going to create another layer for my player, assign my mesh to it, and then make it so my projectiles can't hit my player. That will, it won't do a whole lot because I'm not doing anything when that collision does happen, but it makes sense to do that. And it will just show another example of creating custom layers. So what I'm going to do is I'm going to go into my layer manager again. I believe there is a way to go to it through project settings. Yeah, I'm pretty sure there's a way to get to it, but the way through the menus. But the way I always get to it is I just click on a random game object and go to layer and say add layer. That's like the easiest way to get to it anyway. But what I'm going to go ahead and do is I'm going to create a player layer and a projectile layer. Then, once I've created those two layers, I'm going to go into my prefabs, basic weapons, projectiles, level 1, and I'm going to tell it to be on the projectile layer by clicking this little drop down, going to projectile. And it says, do you want to set the layer to projectile for all child objects as well? Why not? Now let's do the same thing to the player. I'm going to go to player. I'm going to go on layer and I'm going to select player. It's going to ask me the same question. It's going to say, do you want to set layer to player for all child objects as well? And I'll say yes. So now my player and all his objects are on one layer, and my projectiles are all on another layer. So now I can avoid the collision again by going to Edit, Project Settings, Physics, and then looking at this matrix. What I'm going to do is I want the player to not... No, I want the projectile to not hit the player. This matrix is kind of confusing. It's also very difficult to see because it's all like sideways and weird. Player will not hit the projectile, but the projectile will hit other projectiles. Well, why should they? Let's uncheck that as while we're at it. So projectiles can't hit other projectiles. The player can't hit projectiles, and the asteroids can't hit other asteroids. So we won't notice much of a difference because it was very difficult to see in the first place, asteroids colliding with each other. But now we still see that the game still works, but we can prove that this did work, actually very easily. Because if you recall, when we were creating our projectiles previously, they were hitting the mesh. So
Yeah.
what I can do now is I can go into projectile, and I'm simply going to say debug log collision game object, come back into Unity, and I see that that is no longer the case. You see, now they only collide with asteroids. They no longer collide with the player.
Nice.
Now, if you were to introduce enemy ships with their own projectiles, you would obviously want to have two different projectile layers, one for enemy ships and one for you, but that's beside the point. I'm going to go ahead and remove that debug log out.
All right, nice.
Okay, so I now have a way for us to destroy asteroids, and I have them, well, create additional sub-asteroids if they need to. So I think that pretty much wraps up this video.
Awesome. Oh, we should commit.
Yeah, we should. We've been kind of dropping the ball there a little bit.
A little bit.
That's all Steve's fault.
I blame me entirely.
Okay.
All right, sweet.
All right, we'll see you guys in the next video.